even if you're back solving, you have to know the primary relationship between distance, rate, and time. Tell me that formula.
Distance equals rate times time.
Good. Now, if we try to solve this problem algebraically, we have two fairly complicated equations that we have to solve as a system of equations, and we'll come up with the right answer. But it's a lot of work. And when you see a question asking a single thing, how many miles were traveled by the fastest car, always consider back solving it.
Okay.
Okay, it's not asking for, well, yeah, that's a single question about a single thing. All right, so these two cars started at the same spot. One's going 15 miles an hour than the other. At the end of 5 hours, they're 475 miles apart. How far did the fastest car go at least, minimum? Half that distance?
Like
Greater than half that distance? Less than half that distance?
what are you asking? You're asking how far?
How far did the faster car travel? Did he travel more miles or less miles than the slower car?
I thought it would be the same because it's oh, never mind. Sorry, I read it wrong.
You got a car that's moving
Probably
50
more.
miles an hour faster than another one, it's going to travel a lot further in the same amount.
Yeah.
Okay, so it has to be more than half that number. So what can we eliminate immediately from our answers?
Probably E and D.
Not D. A for sure. Only eliminate what you positively know cannot be correct. There's no way the faster car goes 200 miles an hour, leaving the slower car to go 275 miles an hour, or miles, which it would have to go. They're separated by 475. Okay?
Okay.
So the faster car has to go greater than half this distance, and 200 doesn't do it. So now any of these other four theoretically could be correct, because all four of these distances has the faster car going more than half that distance. So if we have precisely four answers, and we're going to back solve it, where do we start?
Well, I don't know, because
You either start at the second low or the second high, which means I either start there or there, since I've eliminated A from being a possible answer.
Okay.
Okay? Just if they're not saying the maximum or minimum, then, and if you're going to back solve it, start with your second low or your second high. Which one's easier to do the math on immediately?
D probably.
Okay? So we're going to assume the faster car goes 300 miles. And that was in 5 hours. What's its speed? The rate of the fast car is what? If it goes 300 miles in 5 hours, what is its speed? R.
60. 60.
Okay. So what would that make the speed of the slower car?
45.
Okay. How far would it go in 5 hours?
225.
And we said the first car went that would have them being 525 miles apart. So 300 is not the correct answer. Furthermore, what else do we know is not the correct answer?
E.
Correct. So now we have to do one more calculation. Based on our number, we only came 50 miles too far. What do you think the best guess is? B or C?
Probably C.
Yeah, I would say C also. Now, the fact is that I can pick either one of them and come up with the answer. Because if I pick B and it's not the correct answer, I know it's C. If I pick C and it's not the correct answer, I know it's B. Okay, so let's do everything. We're going to base it on C because we kind of think that's the correct answer. So the fast car goes 275 miles in 5 hours. What is its speed? The rate of the fast car.
55.
What's that make the speed of the slow car?
40.
Now, we know that goes 275. In 5 hours, what's the slow car go?
200.
Separating them by 475, there's our answer. Okay?
Okay.
Now, turns out if I'd have done this problem a little bit faster and if I'd have followed Sycamore Learning, I would have started with the middle. And I would have got it on the first trial. But I honestly don't think that's the way to do it.
Okay.
Nothing wrong with the way I did it. You don't have to necessarily do this first step, eliminating A. You could start with B as a first step. That'll give you too small a distance. And then you'd try D as a second step. That'll give you too big of a distance, and you'd have your answer. The thing is that with back solving, you almost always only have to test two different possibilities. You never have to go through all 5 of them. Well, you would never go through all 5 of them. The most you'd ever go through would be 4. Because if none of the 4 fit, you'd choose the 5th one and go on. Okay? That's an important concept. If you know the answer, don't prove it. You don't have to. You know what I mean by that, right?
Yeah, don't do the math.
Yeah, if you've eliminated A, B, C, and D, you know E is correct. You don't have to do E to prove that it's correct. All right, I don't know if you can read that or not, but it appears to be about the only way. Let me see if I can just. No, this thing goes up goes up by too many steps at once. Can you read 46?
Yeah.
Okay. Forget everything they said. Just look at the graph.
Okay.
Is B positive or negative?
Negative.
B is the y-intercept.
Oh, I'm sorry. It's positive.
All
I
right.
was thinking about the line in general.
And what's the slope of that line?
It's negative.
Okay. Now what? All we have to do is find the answer that matches that. Right there.
Oh, okay.
It's as simple as that. In other words, don't make some of these harder than they need to be. Now, they're telling you that that's the line. In other words, that cannot be the line. It's the line they're showing you. And clearly the y-intercept's positive. Clearly the slope is negative. That's the only thing they're asking about. I found an answer. 10-second problem. Go on to the next.
Okay.
47. Let's see if I can blow this up 1. Yeah, I can. First of all, tell me how you're going to do this. It's the key part of every question, particularly the harder questions, is the first thing you have to decide is, how am I going to do this? And I got 3 choices. Can I do it algebraically? Can I do it by back solving? Can I pick numbers? Can I just go through every number on there and check it? Which one are we going to use? Of the 3 primary methods, what are we going to do? And here's the flag. There's an X, a Y, and every answer has X and Y in it. What solution works really good for that?
I'm not sure.
Picking numbers. And then,
So if it's all the same, you can just pick numbers.
not if it's all the same, but if they give you some variables in the paragraph, and then they give you variables, the same variables in the answers, that means I can make X and Y anything I want. They are not fixing X and Y. The only thing I can't violate is that. In other words, the absolute value of Y has to be less than the absolute value of X, and they cannot be equal to 0, which means neither one of them can be 0.
Okay.
Okay? So let's pick some X's and Y's and see which one of these might be true.
Okay.
Give me an X and a Y. Just pick anything. Don't pick 0 or 1.
Okay, 8 and 4.
Pick low numbers, as low as possible.
Okay, 3 and 2.
Which one? Okay, so X is 3. Y is 2. That makes that correct. Now, is that a true statement? Must be greater than or equal to 2. Well, that would be 9/4. Yeah, that's greater than or equal to 2. But I can tell that if I made, these don't have to be integers. Nowhere does it say they have to be integers. So if I were to have made X equal 2 and Y equal 1, how about if I make Y equal 1.9? Now I've got 4 squared over almost, what is that, 3.8?
3.61.
Okay. 4 over 3.61. Well, that's not greater than 2. So by picking numbers, I'm able to eliminate some of these answers. I can definitely eliminate that one because I found an X and a Y where that wasn't true. And that's all I have to do. To prove that statement wrong is all I have to do is find an X and a Y that is not greater than or equal to 2. And I just did it. 4 divided by 3.6. Okay?
Okay.
B looks promising. It must be greater than 1. Well, that's greater than 1. That first one was greater than 1. Now, I don't need them to be positive. They could be negative. In other words, what if I make X be -2 and Y be -1?
But isn't the absolute value?
So what would the absolute value of Y be?
1.
What would the absolute value of X be?
2.
So that would be true.
Oh, I thought you meant like negative for like the whole thing.
Well,
Like dividing it negatively.
is I'm trying to pick values for X and Y that agree to these two conditions. That's all I'm trying to do.
Okay.
If I do that, now x squared is positive 4 over 1. Well, that's certainly greater than 1. And it's beginning to look like that could be a really good answer. Because even if I pick, in other words, this part for y has to be less than that part for x, okay?
Okay.
And I'm squaring both of them. So when I square that number, it's going to turn positive and be greater than the square of that number. But let's look at fractions. Fractions might be a little different. What if I make x be 1/2 and y be 1/4? Now, that agrees with everything, correct?
Mm-hmm.
Well, 1/2 squared is 1/4. 1/4 squared is 1/16. That's greater than 1. So I like that. And I have tested 3 different answers. I mean, 3 different choices of numbers. I basically checked that one, I checked that one, I checked this one, negative numbers, and I checked fractions. And every one of them is greater than 1. What would it take for it to be equal to 1? In other words, the next answer says it could equal 1. Wouldn't it take x to be equal to y?
Yeah.
And then that would not be true. If x were equal to y, that would not be true. So
Okay.
it can't be equal to 1. We've already seen that it's definitely not must be less than 1. We've come up with 3 different answers where it was greater than 1. Cannot equal 3/2? Nah, that doesn't make any sense really, not given everything we've done. So at this point, I'm done with the problem. I answer B, I go on, but understand that even doing that the most efficient way took at least 2 minutes, maybe 3 minutes.
Okay.
So you have to decide. Remember, every single problem is worth 1 point. 47 is not worth any more than number 2. Okay? So
Okay.
is it really worth spending 3 minutes to do this? Even if I know for sure I'm going to be able to come up with the answer.
No.
Certainly not the first go around. Because the first go around, you're never sure whether you're going to be able to come up with the answer, even if you spend 10 minutes on it. So that's the reason you go through and do all the easy ones, and then you go through and you do all the medium ones, and then you use whatever time you have left to do the hard ones. Well, what happens is you never have any time left, and that's okay. I would love it if you got 40 out of 40 of the first 40 and missed the last 20. You'd have a heck of a score. There'd be nothing wrong with that ACT math score.
Yeah, what do you think that would be if I did that? Like, what score do you think?
I don't know. The fact of the matter is though, you're going to get the guess on those last 20. So you should get 4 of them. So just guessing, you'd get 44 if that was the case. And that would be a really good score. That would be 80 or 90th percentile. In other words, you can miss a lot of questions. You don't have to get 90% of the problems correct to get into the 90th percentile. That's not the way it works.
Okay.
If you get half of them correct, you're going to get an average score.
If I get how many correct?
Just half. 30 problems out of 60. All right, let's go on. This problem 47, incidentally, fairly tough to do algebraically. I'm not even sure I would know where to start. It's smacks of picking numbers. And like I said, what you want to look for is variables in your question and your answers, which means you can make that variable anything you want, which means you're talking about picking numbers. You just have to be careful. When you're picking numbers like I did, you want to make sure you pick positive numbers. You want to make sure you try some negative numbers. And you want to make sure you try some fractions.
Okay.
Oops. What did I do? Nothing. I'm fine. Now, I don't really believe that it's in our best interest to spend a lot of time on hard problems.
Yeah, because I don't think I would get them.
Since this is our last session. So if I come up with something that I think is really a hard problem, I'm going to pass it by.
Okay.
48. Easy, medium, or hard?
Um, I don't know. I feel like I could figure it out.
There's one very critical thing you need to be able to make this an easy problem. And it's really worth knowing. It just is. And that is, how do you expand a binomial? How do you square a binomial? How do you square that? How do you square this? And you want to do it by memorizing it. In other words, this is such a common problem where you have to square a binomial that you don't want to have to FOIL it every time. Turns out that when you square the top, you get a squared plus 2ab plus b squared. And when you square the bottom, you get a squared minus 2ab plus b squared. If you know both of those, you will recognize instantly what to do with this problem. So what does that equal to?
Um, I'm still not seeing it.
What's that right there?
Oh,
That's what they're asking about. What is the value of a squared minus 2ab plus b squared? Well, first of all, let's go backwards. What is that? If I go in that direction, what does that equal to?
a minus b squared.
Okay, and they just told you what a minus b is. It's 12. So that's equal to 12 squared, 144.
Oh.
That's simple. But you're never going to if you do not recognize what that is, you're never going to get this problem. I mean, you could take some guesses, but it'd be really hard. It's going to be even hard to back solve because they tell you what a minus b is. They don't tell you what a and b are. So the only way I really know how I'm going to do this problem is because I recognize that that is a minus b quantity squared. Why do I recognize it? Because I teach it to students every day of the week, and I do 100 problems a semester that are a minus b squared. And it doesn't have to be a minus b. It could be 2x minus 3y. If I'm squaring that, the answer is going to be 2x squared minus 2 times 2x times minus 3, times plus 3y minus plus 3y squared. That's why it's so valuable. It doesn't just work when you have a plus b. It works when you have any binomial. Whenever you're squaring a binomial, you want to know both of these formulas.
Okay.
Okay? I'm going to give you another problem. I want you to tell me what it is. I meant to write plus 99 squared. That last term is plus 99 squared.
Okay.
Okay? So there's our expression. Now, even with a calculator, that's going to be hard for you to do. Right? Just going to be. You could do it with a calculator. But what if I said you can't use a calculator on this?
Then I would have to figure it out.
Well, look right above. Does this look familiar? What's A and what's B?
Well, 100's A and 99's B.
So that expression is the same as A minus B squared, right?
Uh-huh.
It's the same as 100 minus 99 squared. That's 1. I don't need a calculator to do that problem. In other words, I'm recognizing it in reverse. I'm seeing A squared minus 2AB plus B squared. And I'm realizing that that is the quantity A minus B quantity squared. So if I can figure out what A is, figure out what B is, A minus B is 1, 1 squared is 1, there's my answer. Utilizing the same exact principle that they're trying to get you to recognize in this problem. In other words, the only way I know how to do this problem is to recognize that that is A minus B squared. And you just kind of have to know it. And here, let me go back to this page so I can get rid of my scribbling. Easy, medium, or hard?
I feel like I could do it. I just have to write out
It's easy.
stuff.
Yeah, let's just draw a triangle and start labeling some of these. DEF. So if I call that DEF, they're saying DEF is 30 degrees greater than the measure of EDF, and EDF is 15 degrees measure of both of those. So we need to introduce a variable. How do we know that? If we look at our answers, they all have an X in them. Okay? That's the angle I'm going to call X. Because now what is E?
30 times greater, so
30
30x.
degrees greater. So that's X plus 30, right? Now what is F? Let's see. And the measure of EFD, which is F, is 15 degrees less than the sum of the other two. So what's the measure of F?
Wait, it's less than the sum of both of those?
EFD, which is this one right here, is 15 degrees less then the sum of the measures of the other two, well, there's the other two. The sum of those is 2x plus 30. 15 degrees less than that is 2x plus 15. So I would say that's 2x plus 15, except now I have a real problem. Oh, no, I don't. That's what they were asking about. I'm done.
Oh, okay.
In other words, the key to this problem, and I didn't have to make angle dx. I could have actually made that be x, and this would be x minus 30, right?
Mm-hmm.
And then the sum would be x and x minus 30, and it's 15 degrees less than that. Huh, interesting. It gives you a different answer, doesn't it? 15 degrees less than the sum. The sum is 2x minus 30 minus 15. I would get an answer that isn't on here. So it actually appears, I think that I might have made a math mistake because I can't imagine that it matters. But you don't want to work with negative signs if you can help it anyway, right?
Mm-hmm.
So if I have to choose which one to make x, E or D, I'm making dx because it tells me that E is 30 degrees greater than D. So this is clearly x plus 30. So now I got an x and an x plus 30, and I'm basically done with the problem. The other angle is the sum of those two, which is 2x plus 30 minus 15 gives you 2x plus 15. All right. Another parallel line, transversal. Only I would expect this to be harder just because it's number 50, and yet there's a lot less lines on this thing.
Mm-hmm.
It says CD and AB are parallel, so gosh, we know that. How tough could this be? If CRP is 110 degrees, that's that one, then what is the measure of ATQ? ATQ has to be that one right there. What is it?
Yeah, shouldn't that be easy?
Very
70?
70, exactly. That's the obtuse angle. That's the acute angle. That's all you have to know. So another example of, the last few are not always the hardest ones. Let's say the last 10. And just another thought on this one. If you didn't know anything about math at all and you were just judging angles, that certainly is not 110. It's certainly not 90. It's certainly not 30. So you're down to a 50-50 guess if you don't know math at all, just by looking at that angle. I don't know which of those two I would guess from trying to look at that angle. I might guess 50, but at least you're down to a 50-50. Oh, hold on, gotta go to another page. Okay, good, another trig problem. These tricky devils. Easy, medium, or hard?
I don't know, because I've never had to square like sine or cosine.
What is sine squared? That's how you write it. It's this way. In other words, if I just do a direct substitution, I get sine squared of theta plus cosine squared of theta. What's that always equal to? That's a Pythagorean trig identity. Had to memorize it.
Oh, 1.
Yes. Easy problem, as easy as they get. And notice that that's irrelevant. Don't need that. There ain't no z in this thing. It's always 1. Sine squared plus cosine squared. Again, easy, medium, or hard? First of all, let's ask a couple questions. What is the slope of two parallel lines?
It's the same.
Okay. So these are parallel lines. So the first thing we need to do is figure out the slope of this line. How do you figure out the slope of that line?
You have to get y alone. So
do it. In other words, read me the next line. Okay, I'll write it. We got to solve that for y.
So subtract 3x from both sides.
Give me the next, just read each line to me.
Okay, so negative 5y equals 4 minus 3y.
Minus 3x.
Oh, sorry.
Now, I'm going to put the x first, not last. Why? Because I'm trying to get it into y equal mx plus b format. If I put that minus 3x where you would normally put it, you may not recognize it properly. But if I put it up front, all of a sudden it's starting to look like y equal mx plus b. Now, what is y equal to?
Y is equal to negative 3/5 x minus 4/5.
Well, the first part is not negative 3/5. Negative 3 divided by negative 5 is a positive 3.
Oh.
Minus 4/5. So that's the equation of the original line. And they want to know what's the equation of a line that is parallel to this line, only has a y-intercept of minus 3. Which equation in that f through k is parallel to this line, only has a y-intercept of minus 3?
Okay.
Good. Again, not a hard problem. Now, they don't get any easier than this. That's why I'm always reluctant to skip some of these harder ones, because they're not always hard.
Yeah. So is it just 9?
Mm-hmm. You could do this 100 different ways. You could do 5 minus a negative 4, which is equal to 9. I could count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Could get it that way. I'm not sure that you can be sure if your test is going to have easy problems in the 50s, but
like it's standardized, right? So they should all be similar.
yes and no. In other words, you got a bunch of services out there. You got Kaplan, you got Barron's, you got Princeton Review, and they all put out their own test booklets, just a little different. McGraw-Hill. the best test booklet is probably the one put out by the people that put out the test. I have some of those, but I haven't digitized them into my computer, and you
Yeah,
have some of those also. No, you
yeah,
don't.
online.
You have Barron's. You have Barron's practice test.
No, because I have an online thing and
Okay,
it has
that's put
the
out by the College
official
Board.
ACT, so I
Yeah,
do.
College Board does the SAT, and I think they also do the ACT. And if you go to their practice tests online, that's as good a measure as you can find as to how the test is going to actually look. Although all of these problems we're doing here, what we're doing is reviewing basic math is what we're doing. Nothing less. So this is all going to be very helpful, even if this isn't uh, an adequate model for questions 50 through 60. But let's take a look at 54. If you don't immediately know, what should I do?
Graph it. Like make a diagram.
Label. What is that point right there? A.
0, 5.
Comma 5. They're telling us A, B, and C are 0, comma 5. Now, even though it doesn't look like that, that's 5, comma 5. And C is 3, comma 3. What is this distance right there?
From that to 2. What?
What is the distance from C measured perpendicularly to that line?
Did I just subtract?
Uh-huh.
Yeah, so 2.
The y coordinate on C is 3. The y coordinate on both A and B is 5. So this coordinate has to be also 5. And so it's the distance between 5 and 3. And don't worry about the fact that oh no, this is drawn to scale. Yeah, no, this is correct. In other words, that right there is 0. And that's 0, 5. Yeah, no, they don't get any easier than this problem.
Wait, so what's the answer? I'm still confused.
Okay. When you're measuring a vertical distance on the xy coordinate plane, it's just the difference between y coordinates.
Oh. Oh, I got it.
There's a point up here. I don't care what its x coordinate is. If its y coordinate is 7, and I am drawing a line that is perpendicular to the x-axis, and that has an x coordinate and a y coordinate of 1, well, I know the distance has to be 6 because it's a vertically measured distance. It's not at an angle at all. So the key on this point is that right there. What's the shortest distance? And the shortest distance is always measured perpendicularly. If you're looking for the shortest distance from a point to a line, you always measure it perpendicularly. How are we gonna, is this easy, medium, or hard? 55.
Um, Probably easy if I just solve the
Yeah, just solve it.
equation.
Just solve it. Just got to make sure you know how to solve an inequality. So let's solve that. What's first step?
You just add 4x to each side.
Okay, that's one way to do it. I'll go for that. Next step.
You have to divide, but then when you divide by negative, you have to switch the sign.
Okay, so
So it would just
read the
be
next
1.
line. Read the next line to me.
So 1 is greater than or equal to x.
Now find the answer. That's the correct algebra. Which answer is that?
So B.
Nope, that says x is greater than or equal to 1.
Right? B, right? Isn't that?
What's B say? It doesn't say what we just did.
Oh, I'm sorry. I was just looking at the sign.
Okay, they did that on purpose. They did it on purpose so that the normal way you would solve it, you would end up with x on the right side of this inequality. Well, on our answers, x is on the left side. So what is that equivalent to?
E.
Yeah. In other words, if you want to switch sides, you just switch the inequality sign also. So whenever you end up with x on the right, it can be a little confusing for everybody. But just put it back on the left. Now, I might have done this a little different way. I might have brought the minus 6x over to the left because that gives me a positive coefficient. I don't have to worry about doing any switching of directions. I move the 2 on the right, boom. I'm there, no confusion, no x on the other side, instantly. So when you're solving an inequality and you have to decide which side to put x on, it's safer to put it on the side that's going to give it a positive coefficient. Because if you put it on the other side like you did, it's fine. You can still divide by a minus 2 as long as you switch the direction of that thing. But that's one extra thing you have to remember to do. And that can be hard to do. And the way you did it, you dealt with 2 extra difficult tech steps. One, you had to handle a negative coefficient in front of the x, and then you had an answer where x was on the right side of the inequality, and you had to figure out which one to match it up to. So either one of those could have produced a mistake. Whereas if you bring the 6x to the left first, and you take the minus 2 to the right, everything comes out beautiful, simple, 2 steps, you can't make a mistake.
Okay.
Got just enough time to cover this last problem. And problems like these, I don't need the answers. They're not going to do me any good, right?
Okay. Yeah.
This being multiple choice is no better than it being answered by a grid. Multiple choice, I can't do anything with the multiple choice. What I have to do is work with this figure and break it up. Okay?
Okay.
Now, I can do it a couple of ways. I can try to break it up into rectangles. And then I got that area, that area, that area, that area, and that area. That actually should work pretty good, right? That can't be that hard, although I don't know this dimension.
Wait, would it work if I just found the area of just do 8 times 10 and then subtract 12 and 6?
Beautiful. That's what I was getting at. In other words, problems like these can frequently be done using subtraction as opposed to addition. If I do addition, I've got to figure out some of these dimensions, which is going to be hard, and then I got to add the 5 areas that I'm dealing with. Whereas the way you did it, you dealt with that outside area, figured out the area of it, and subtracted off the two inside areas. And that's almost always the way they want you to do it. It's kind of like a shaded area problem. Okay? If they give you a shaded area problem, figure out the area of the shaded region, and they give you the radius of the circle, well, you don't figure out the area of that triangle. You figure out, well, I'm sorry, I meant the rest of it. I shaded the wrong part. But you figure out the area of the circle, you subtract off the area of the triangle, and that gives you the area of the rest of it. And the area of the rest of it's hard to get by any other manner. Usually shaded region problems are 100% of the time subtraction problems. They are not addition problems. Occasionally, but not very often. And this is basically a shaded area problem. They want to know the area of this shaded area. Well, that's the area of the outside rectangle minus the two white ones inside, but all of which are easy to calculate. All right. Very good. Haley, good luck.
Okay, thank you so much for all your help.
You're welcome. I hope you improve your score a little bit. You're a junior, right?
Well, I'm going to be a senior next year, but yeah.
Senior next year, but you still have more chances to take it.
Yeah.
This area.
Yeah, I still have
a
couple that I can do. So,
well,
thank you so much.
Back to you. Nice work.
And has my mom paid you yet?
No, I will send her an invoice for the last 4 sessions.
Okay, yeah.
By tomorrow, and then she can just pay by PayPal if she wants.
Okay, perfect.
Or a
Thank
check.
you.
If she wants to mail me a check, that's fine also.
Okay, perfect. Thank you so much.
Talk to you later.
Okay, thank you.